Hello, water droplets. Welcome to the West Mech water treatment class. Today, we will be doing a nice arsenic removal lab. We'll teach y'all how to do it, the importance of it, why we do it, and how we do it. Peace out, water droplets, and keep dripping.
Here's the setup. That's what we got going on. To remove arsenic. Fit check. So this is well water. And we're gonna test its pH. Okay, so in order to collect a pH sample, we have to first collect a sample of the water that we are going to test. More? Once we have a small sample of water, we quickly dip the pH strip in the water, and then based on what color it is, we compare it to this chart and see what the pH level is. This specific sample happened to have a pH level of 7, which you can see is in the middle.
So this right here is the jar test apparatus. We use this to see how much turbidity, viscosity, and all that other stuff of the water that's, dirty. In this case, this water right here has a lot of arsenic in it. You don't see it. You don't see it, just trace amounts. You feel me? So right now we just, doing a little water apparatus test. And looking to add the HCl droppers, hydrochloric acid, which is a good way to get the coagulation process. So the reason why we always mix our solutions with high speed so the mixing process could occur, and the chemical could do its thing. Eventually we'll slow it down, because if it's too fast or too long, those issues start breaking back apart again. So right now it's gonna be high speed, in a little bit, 2-3 minutes from here, and then back to low speed.
Explain to them.
Alright, so we just added the ferric acid to the mixture, and it's just as dangerous as HCl, so be careful with both of these mixtures.
As you can see, as soon as the ferric chloride is added, the solution immediately turns yellow.
We're going to change the mixing speed. Like I said last time, you don't want it too fast or too long. You don't want it too slow. So right now, right when the timer goes off, we're going to set it to medium mixing for a good 4 to 5 minutes. We just got back from our 5 minutes of medium mixing, and now we are doing our 20 minutes of mixing. We just added some more ferric acid to the mixture, as you can see.
Starting to turn yellow. Okay, then we slowed it to medium, and now we're gonna wait and see what happens for any change. Now we're letting it go to the slowest way possible for about 20 minutes, so that way we can let it fluctuate. Now we're going on break for 20 minutes while we let that sit and flocculate. So after our break, we came back and there was no flocculation. So we decided to add more ferric acid, ferric chloride, and we're gonna see what happens. We doubled the amount of ferric chloride.
Ferric acid? Yeah, this says danger, and it's not lying. Do not drink it.
Now we are doing 20 minutes of mixing. We just added some more ferric acid to the mixture, as you can see. notice if you have too much in your pipette, then it doesn't matter. Just put it in there. Do not drain. No chemicals.
Okay, so as y'all can see, we miserably failed, but we could have done different. It's probably just have more like different water samples, so then that way we can know each difference of the water.
We failed. Yeah. Today is lab day 2 of the arsenic removal, and we're gonna see what happened overnight. So what we discovered is that all of the samples had changed colors based on their pH level. And what you see here is pH 13, and that is what we were going to use to make the pH go higher, which would allow these mixtures to coagulate and flocculate, which basically just means that we would be able to extract any of the suspended particles by making them clump together. And here you can see we are testing the pH of the samples. We kind of tested the pH of the samples all throughout the process because we were adding different things in different amounts. And after everything we added, we would retest the pH just to see how much it was and what we needed to do to fix it or change it. So here you can see that it's starting to flocculate, and you can see the suspended particles floating in the water. And in the jars on top, which you can see right here, you can tell that overnight the suspended particles that flocculated together actually sedimentated to the very bottom, separating them from the actual water so that the contaminants were being extracted through flocculation. As I said before, through this entire process, we continuously checked the pH because the whole point was that the samples would only coagulate and flocculate if they were at a certain pH. So we would add pH 13 to increase the pH, which is the acidity, which is basically just the unwanted extra chemicals in the water. So we were trying to increase the pH so that we could extract the chemicals and extract the contaminants and the suspended particles through coagulation and flocculation. The coagulants that we used in day 1 of the lab was the ferric acid and the HCl, but since that didn't work, we knew something was wrong with the samples, which is why here you can see that we're adding pH 13 to rebalance the pH. After rapid and slow mixing the solution with the pH 13 in it, we were able to start seeing some results and some success with the flocculation process, as we did start seeing some suspended particles floating in the water, and they would eventually sediment to the bottom so that we could collect them, which is what you do in a regular water treatment process. For the next few clips, you will see us repeat the process of adding pH 13 until we got the results that we wanted. When you add pH 13, the pH level goes up. So success.
Alright, so we just got done doing the lab. It was fun, very dangerous since we dealt with like 30 billion different types of different
Very educational.
nasty chemicals. Yes, we learned a lot. Have a good day, water droplets.